Let's work through this geometry problem carefully, step by step, and pay close attention to why each equation works. We have a right triangle PQR with angle Q equal to 90 degrees. The side PQ is 18 units, and the side QR is 24 units. Inside this triangle, we have a semicircle whose diameter lies along QR. Its center is O, and it touches the side PQ at Q and the hypotenuse PR at D. The other endpoint of the diameter is E. Our goal is to find the exact area of the shaded semicircle. So, let's begin by calling the radius of the semicircle lowercase r. Because QO is a radius and PQ touches the semicircle at Q, the radius QO is perpendicular to the tangent PQ. That gives us a right angle at Q, which is consistent with the fact that triangle PQR is a right triangle. Now let's focus on the large right triangle PQR. We already know two of its legs. PQ is 18 units and QR is 24 units. To find the hypotenuse PR, we use the Pythagorean theorem. Remember, in a right triangle, the square of the hypotenuse equals the sum of the squares of the two legs. So we can write PR squared equals PQ squared plus QR squared. Now substitute the values we know. PR squared equals 18 squared plus 24 squared. 18 squared is 324, and 24 squared is 576. Therefore, PR squared equals 324 plus 576. That gives us 900. So PR squared equals 900. Taking the positive square root, because the length must be positive, we get PR equals 30 units. So now our large right triangle has side lengths 18, 24, and 30 units. Next, we need to determine how much of the hypotenuse is occupied by the segment DR. This is where the equal tangents theorem becomes useful. The theorem tells us that if two tangent segments are drawn from the same external point to a circle, those two tangent segments have equal lengths. Here, our external point is P. One tangent segment is PQ, which touches the semicircle at Q, and the other tangent segment is PD, which touches the semicircle at D. Therefore, by the equal tangents theorem, PQ equals PD. Since PQ is 18 units, PD must also be 18 units. Now remember that the entire hypotenuse PR is 30 units. The hypotenuse is divided into two parts, PD and DR. So we can find DR by subtracting PD from PR. In spoken form, DR equals PR minus PD. Substitute the values and we get DR equals 30 minus 18. Therefore, DR equals 12 units. So we now know that the small segment of the hypotenuse from D to R has length 12 units. But our main goal is still to find the radius of the semicircle. So let's focus on that. Since QO and OE are both radii of the same semicircle, they have equal lengths. We define the radius as r, so QO equals OE equals r. We also know that the entire segment QR is 24 units. Since O lies between Q and E lies on QR, the distance from O toward R can be expressed by subtracting the radius QO from the whole length, QR. Therefore, OR equals QR minus QO. Substituting the known values gives us OR equals 24 minus R. Now we need one more useful right triangle. Connect the center O to the point of tangency D. The segment OD is a radius of the semicircle, so OD equals R. Because PR is tangent to the semicircle at D, the radius OD must be perpendicular to the tangent line PR. Therefore, angle ODR is 90 degrees. That means triangle ODR is a right triangle. Now let's identify all three sides of this smaller right triangle. One leg is OD, which is the radius, so OD equals R. The other leg is DR, which we already calculated as 12 units. And the hypotenuse is OR, which we found to be 24 minus R. This is the key step because now we can use the Pythagorean theorem again. For this right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. Therefore, we have R squared plus 12 squared equals the quantity 24 minus R all squared. Let's simplify this carefully. 12 squared is 144, so the left side becomes R squared plus 144. Now we expand the quantity, the 24 minus R, all squared. Remember the identity. The quantity, A minus B all squared equals A squared minus 2, multiplied by A multiplied by B plus B squared. Applying that identity here, the quantity 24 minus R, all squared, becomes 24 squared minus 2, multiplied by 24 multiplied by R plus R squared. 24 squared is 576, and 2 multiplied by 24 is 48. So the equation becomes R squared plus 144 equals 576 minus 48R plus R squared. Now notice something very important. There is an R squared on both sides of the equation. Since the same quantity appears on both sides, we can subtract R squared from both sides, and those two terms cancel. That leaves us with 144 equals 576 minus 48R. Now we want to isolate R. Let's move the term involving R to the other side. We can do that by adding 48R to both sides. At the same time, we can move 144 to the right side by subtracting it from both sides. This gives us 48R equals 576 minus 144. Now, calculate that difference. 576 minus 144 equals 432. Therefore, 40R equals 432. To isolate R, divide both sides by 48, so R equals 432 divided by 48. Which gives us 9. Therefore, the radius of our semicircle is 9 units. Now we have everything we need to calculate the shaded area. Remember, the area of a complete circle is pi multiplied by R squared. But we only have a semicircle, which is exactly 1/2 of a full circle. Therefore, the area of the semicircle equals 1/2 multiplied by pi multiplied by R squared. We have just found that R equals 9, so now substitute 9 for the radius. The area equals 1/2 multiplied by pi multiplied by 9 squared. 9 squared is 81, so the area becomes 1/2 multiplied by pi multiplied by 81. Therefore, the exact area is 81 pi divided by 2 square units. That is our exact answer. If we also want a decimal approximation, we can use pi approximately equal to 3.14159. So 81 pi divided by 2 is approximately 127.23 square units. Therefore, after carefully working through the geometry, the radius of the shaded semicircle is 9 units, and the exact area of the shaded semicircle is 81 pi divided by 2 square units, or approximately 127.23 square units. If this explanation helped you understand the geometry, please take a moment to like the video, subscribe to the channel, and leave a comment with your answer or your preferred method of solving this problem.